Hi guys, welcome back to another video, and this video is very different as you may notice than my other videos, and it's because I'm doing a walkthrough of the papers that I did last year where I got top in the world, and this video will cover paper 1 and my next video will cover paper 2. So I did the second variant of May-June 2025, and for my physical paper I got 51 out of 60, which was enough to get me top in the world when you combine it with my human geography paper. So I'm just going to go through this paper, giving you some tips and tricks, how I approach the question in the exam, and how you can improve, be better than me, and get full marks, essentially. So without further ado, let's get into it. So section A is, you have to answer everything, essentially. You have to answer every question when you have 3 topics. You have the rivers and stuff over here, you have atmosphere over here, and you have rocks and weathering over here. These questions, especially the first few questions, relate to the insert which you're also given. So you're given like diagrams and statistics and tables and stuff, which you have to analyze and provide data points for. So yeah, question 1 of hydro and fluvial geomorphology is relating to Fig 1.1 and 1.2, which is this diagram, this figure. And it shows the groundwater depth of India in May 2019 and January 2020. The first few marks for A parts are basically 3 marks, and it's because you're just looking at a diagram and saying what it says, right? It asks, state the depth of groundwater at X in Fig 1.1. X is pointing to a yellow part, so you just say this yellow part, which is 5.0 to 9.9 meters below ground level, and you get 1 free mark. It's just user insert, essentially. 1B is a bit harder, where you have to kind of manipulate the data a bit and answer in words instead of just data. And for these questions, when they're asking you to compare, so similarities and differences, you have to make sure that you're linking the 2 differences or similarities together. You can't just say, at this day you have, on May 2019 you have this, on January 2020 you have this. You have to relate them somehow. So for example, it's easy to spot differences over here. As you can see, like there's a lot of color changing. So and in fact, I did only get my differences points. I got 2 out of 4 for this, and that's because I didn't get my similarities. But for differences, you can easily see the groundwater level for January 2020 is much closer to ground than May 2019, with less green and less this color, yellow and blue as well. And you can basically say that. So in January 2020, the groundwater depth was much closer to the ground than May 2019, as there are more spots of yellow, green, blue, which are 9.920 meters below ground level, and that's one statement. Another difference you can spot is perhaps the red areas. So in red areas over here, and there are some spots like here, here, and here and here. Whereas in January 2020, you don't see any red spots. And that is one difference. So you can say that in May 2019, there are some spots with groundwater level even deeper than 40 meters, but in January 2020, there aren't. And that's 2 easy difference marks. For similarities in this figure, it's much more difficult to visualize because you can really see the differences, and that kind of clouds your judgment on what similarities there are. But you can look at like some general areas. So for example, in the northwest over here, the groundwater is still quite low, right? If you compare it over here and here, there's still a lot of these pink and brown parts. So a similarity can be in the northwest, the groundwater is still deep at around this level. Another similarity, this area is kind of deep as well, which you can mention. This area is kind of deep as well. And you use geographical terms like this is the central and south. This is more towards the east of India. And you just say that. So in the northwest, it's deeper. In the northwest, it's deeper. And that's a similarity between those 2, same as in the central area. And you get 2 similarities marks. In the exam, I panicked, and that's why I couldn't find the 2 similarities. But it's kind of simple, as you can see here. Just find the major spots. Like, you should see that there are hot spots over here of deep groundwater. And so when you're panicking an exam, just try to calm down and see the map more holistically and try to remove any of these colored things that might cloud your judgment. For 1C, I also didn't do that well. I only got 2 out of 5 marks over here. But I'll give you some tips for you to get 5 marks, right? So as you can see here, it's out of 5 marks. So what you can do is you can write 5 points. So 1 mark per point, or you can do 3 detailed points. So you can get 2 marks for 2 points and 1 mark for another point. I wrote 3 marks, but I didn't get any development points. That's why I only got 2 out of 5. So if you can think of 5 points, it's kind of simple. You just write them down and you get the 5 marks. But if you can't, try to add more detail. For example, examples. Examples are details or just in-depth explanation, and you might be able to get the details if you can't get the 5 points. So what is the reason for the difference between here and here? Well, number 1, it can be there was more rain so that the groundwater could recharge to higher levels. So you can say there's more precipitation. I can't write over here, but more precipitation. Detail could be because it was a monsoon season, so there was seasonal rainfall that meant groundwater could recharge over here, whereas before May 2019, where the data was covered, there wasn't a rainy season, there was a monsoon, it was a dry season, so groundwater couldn't recharge. Another reason why groundwater levels can be deeper or higher for January 2020 is because there is less evaporation. So less evaporation because it might be winter time. So January 2020 is winter time, so it's much colder. Temperatures are lower, and therefore you get less evaporation. Whereas in May 2019, it's closer to summertime, so you have more, you have higher temperatures, and therefore you will get more evaporation. So you can say more evaporation. A third point is you can think about humans, the human side. A use for groundwater is for agriculture. So you might say around January 2020, for some reason, due to some seasonal crop issue or something, they had to take out more water. Or perhaps you can link back to there's low precipitation in May 2019, so that they had to abstract more water from the groundwater sources in May 2019 for agriculture use. Whereas in January 2020, because there were more precipitation, there wasn't as much need for abstraction. So number 3 is abstraction. My handwriting isn't that good on computer, so I apologize for that. I'll just remove these things. So as you can see here, it's quite simple to get full marks for section A parts. It's just that you have to make sure you get in the detail. You can't just explain one thing and move on. Make sure you explain it in detail, add some examples. Even just saying monsoon rain, right? That is a detail which can get you mark, which I missed out on. So try to make sure you fill in the gaps. 10 minutes is easy to get those on. This one you can get it in like 5 seconds. This one maybe a bit harder, but you can complete it in 4 minutes. This one you can complete it in 5 or 6 minutes, right? And that's easy 10 marks. I got 5 marks out of this, 5 out of 10, which is very dreadful. And I hope I would have gotten more, but oh well. Moving on to atmosphere and weather. You're going to move on to this insert over here, which is the areas of greatest concern from climate-related impacts of global warming. And question AI and AII are just using the figures. So state the least common climate-related impact shown in Fig 2.1. So you basically count. For extreme heat stress risk, you can see that it's everywhere, so it's definitely not that. For river flooding, there is 1, 2, 3, 4 areas, so there might be that. Fire weather risk, there's 1, 2, 3, 4, 5, 6 everywhere, so it's definitely not that. drought is 1, 2, 3. So the lowest is droughts, and therefore you can say droughts, and that's a free mark. State the number of climate-related impacts identified in area X. So identify area X, that is a yellowish color, so it's 1. Say 1, and you get another mark. Easy as that. Right? These data things you should get 1 mark on. You should get the free mark, and that can set you up in a good position. For question 2b, I got 2 out of 3, and it says describe the pattern shown in Fig 2.1. So what's this pattern overall? And use the marks as your pointer as to how many points of paragraphs or sentences you should write. So because there's 3 marks over here, you should write 3 points. So it's relatively easy, and any pattern, right? So you can talk about the climate-related impacts or the number of climate-related impacts. You can talk about how inland areas, like you can see over here around the Amazon in Brazil, and around here, and around here in Africa, and around here in South Asia, the inland areas have higher numbers of climate-related impacts, and you can just use you can just mention the inside of the Amazon has 4 compared to the coastal areas where there is less at 1 or 2. Another pattern could be the fact that as you move towards the as you're in the equator, which is around here, you can see there's significantly more number of climate-related impacts, but as you move closer to the northern hemisphere, you get a decrease in that, and that is another pattern as well. An interesting thing to point out in the mark scheme is that you get 2 separate points for mentioning that. So number 1, you have to talk about how around the equator there is a higher number of climate-related impacts, and you get another mark for saying that as you move away from the equator towards the northern hemisphere, the number of climate-related impacts decreases. And that's 2 or 3 patterns over here, but if you want another pattern, you can talk about the islands. The fact that islands like Madagascar, around Indonesia and the Philippines, the Caribbeans don't have much climate-related impacts, whereas in continental areas, you get a lot of that, and that's not a pattern you can mention. So that's 3 marks ticked off, and now you have to suggest reasons. I got 3 out of 5 because I didn't, again, get detailed points. Remember, there's 5 marks, so you either use 5 points or 3 detailed points. I went with the 3 detailed points approach, but the examiner didn't like me, so I didn't get my detailed marks. But it's relatively simple over here, right? The reason why, for example, around the equator is more climate-related impacts, more heat impacts, for example, is because it receives the highest concentration of insolation or sunlight, and therefore it is at higher risk of heat-related issues. And also another reason why is because of the thickness of the atmosphere. When you move towards the higher latitudes, the atmosphere is much thicker, which means that there's more scattering of light, more heat is trapped by the greenhouse gases, and therefore there's less heat that is reaching around the northern hemisphere compared to the south, and therefore you have higher climate-related impacts closer to the equator. Inland areas also, if you describe inland areas as a pattern, that's because the oceans can act as regulations of temperatures. They can bring in sea breezes, which cool down coastal areas, so there's less heat-related issues. Whereas in land, there is a higher heat capacity, which means it can absorb more heat and increase in temperatures way faster than the ocean. And then coastal areas, which means it will have more climate-related impact, essentially. You can also talk about the influence of flooding. So flooding over here, as you can see, it happens mainly around the equator, and you can see in North America, in Australasia, in South Africa, you don't really get these flooding issues. You only get them around the equator, and that's because there's more evaporation which leads to more rainfall and therefore more flooding. So that's another 5 marks you can get. For this question 2, I got 7 out of 10, which is pretty okay, I think. Alright, rocks and weathering. This is my most favorite topic of physical geography, and I got full marks for this one. I got 10 out of 10. So let's go down into this. Name the type of weathering shown in Fig 3.1. Immediately, you can spot ice, and the only thing you learn about weathering relating to ice is freeze-thaw weathering. So just write freeze-thaw weathering, and you get 1 mark. Number 3B, with the aid of a diagram, describe the weathering process you named in A. So this is very theoretical. You can easily get a 4 marks. If you watch my video on freeze-thaw weathering, just draw something like this, water filling in, expanding cracks, use a diagram to explain it, and you get an easy 4 marks, right? There's nothing you have to think about. It's just theory that you learned. So after you draw a diagram, you can talk about the fact that temperature has to fluctuate around 0 degrees. Water enters cracks, it freezes and expands, putting a 9% pressure. Expands by 9%, putting pressure on the rock, which cracks it, and then it thaws, which repeats the cycle, and that's 4 marks easily. For 3C, it's explain how the amount of rainfall can affect the type and rate of weathering. So this question is kind of mean, I think. It's 5 marks, and you have to explain both type and rates in relation to rainfall. But it's very doable, and I wrote too much for this, I believe. I wrote like more than a page, which you don't have to do to get 5 marks. For the rates of weathering, the Peltier's diagram is very useful if you can remember. It's something like this. Basically saying how for high rainfall, which rainfall is over here, the higher rainfall, the stronger the chemical, stronger rates of chemical weathering there is. High rainfall is also perhaps needed for some physical weathering because over here there's like an area of low weathering overall, and you need some rainfall to enable the physical weathering. In fact, I did an entire video on this, and I did it because I was influenced by this question, and I just want to share. So if you watch that video, it's an easy 5 marks for you. So that is explaining the rates of weathering. Another impact of rainfall can be also rain is needed to pick up the material and wash it away, either through solution or just putting in suspension. So it needs to wash away the weathered material to expose more surfaces for weathering. So for example, this is like a surface, it has been weathered away, but the rainfall brings the weathered material out to expose more of that to weather away. So that again can increase your rate of weathering. As for the type of weathering, it was in the same video where I did the rate of weathering, I believe, and basically you're saying how water is very essential in chemical weathering. It's essential in all chemical weathering processes, in hydrolysis, hydration, everything requires water. And for some physical, especially freeze-thaw weathering, you need water. For dilatation, you might need some water. For onion skin weathering, you also need a bit of water to start the process. And you don't have to just mention chemical and physical weathering. You can also talk about biological weathering, where rainfall is necessary for plants and trees to grow, which allows for roots to grow and crack open rocks through weathering. There's a lot of points you can talk about. It just depends on what you prefer, what you think is easier to write, and you can write the fastest. Just write down 5 points and you get 5 marks. As you can see, I got 10 out of 10 here because I believe this is kind of the easy one. You can get 5 marks over here because it's all theory and just looking at the diagram. And for this last one, it's also very theoretical, and you can talk about way more than these things that require you to reference the diagram in the inserts. So that sums up section A. As you can see, it's really simple to get the marks. You just try not to overcomplicate things, because it really just requires you to use the inserts and provide very simple and brief explanations of stuff. And sometimes if you want some detail, just drop in examples, like monsoon rain, like even here in the Amazon, how you know that the equator has less rainfall. The equator has more rainfall because of high evaporation. All these are good details to put in, and you should, it is very possible for you to get 30 out of 30 in this section. It's unfortunately that I didn't. I only got 22 out of 30 for this part. So you can do way better than me, and I believe you can if you just implement my tips and tricks. For section B, this part I did significantly well on, and this is where you pick one topic to specialize in. I chose rocks and weathering, so I'm just going to go into that and not go through these two, especially not atmosphere and weather. The case study questions for this is very, very bad, and you can't really implement it that much. So I recommend you either do hydrology and rocks and weathering, but primarily rocks and weathering because you can drop in easier examples than hydrology. For section B, I got 29 out of 30, so I only lost 1 mark, which was in my 15 marker. So I got 4 marks, 3 marks, 8 marks, and 14 out of 15. In section B questions, you don't get any diagrams, and you just have to use it all based on your memory of what you have learned. So going on 6A, I briefly describe 2 types of plate boundaries. And since there are 4 types of plate boundaries, there are collision, convergent, divergent, and also transform or conservative. Just pick the 2 simplest one you can talk about and explain. Describe only. You only have to describe. So if you find this very easy, just say convection currents, 2 plates moving together towards each other and one subducting. The denser one subducting, and that's 2 marks over there. You can draw diagrams, whichever is easier for you. You can draw a transform if you want, which is like this, moving opposite direction or same direction in the different speeds. And yeah, it's easy 4 marks. And one thing I want to note for physical geography especially is that diagrams are very easy marks you can do. You can draw a diagram and add some words, and you can get the marks. In the mark scheme, it explicitly credits the use of diagrams. So draw diagrams in physical geography. You get easy marks because it helps the examiner visualize what you're trying to say. For 6I, I briefly explain the location of ocean trenches, and this should be another easy 3 marks because it's just theory. It's when plates subduct. So you have to talk about converging plate boundaries, and they subduct, and then when they subduct, it's scraping off material in the accretionary wedge, and this is the trench. This is location on the trench, and you're explaining it because it requires subduction, and it's parallel to the subduction zone, the Benioff zone, or the coast, and you can use a diagram example. It's like I drew a diagram where I talked about it, and you can see the process happening. So that's another example of why diagrams are so important in physical geography. It's just really nice to have, and you should be able to get 3 easy marks over here. For 6B, explain the movements of water and sediments on the surface of slopes. And again, draw diagrams. You can draw so many diagrams for this. In physical geography, you learn 3 things. You learn about sheet wash, you learn about rain splash erosion, and you learn about rills. But in the video where I talked about this, I went further and talked about gullies, which I included in my exam, and that's how I got 8 marks. For large questions where you get 8 marks or 7 marks, especially B and C questions, you have to use examples. In the mark scheme, it explicitly says you have to integrate examples in. So whatever you can, just try to add examples. It doesn't have to be exact and you don't have to know it, but apply some examples that can imply certain things. If you don't understand, I'm going to go into right now. But to split up the 8 marks, you can talk about you can think of it as 3 marks for maybe sheet wash erosion, 3 marks for rain splash, 2 marks for rills. These questions have a lot of theory in them, so try to remember as much as you can and put them in. So for example, for rain splash erosion, you don't really need a definition because it's self-explanatory, so you can just draw a diagram of this rainwater splashing down and it dislodges material up and down. So you draw this diagram, you explain it in words a bit, and then you talk about some interesting facts. Like you can talk about how it is the most effective at 33 to 45 degrees of slope, and also when the soil is loose, so before rainfall events. And you can talk about an example of this. So think about anywhere with intense rainfall, large droplets of rain. If you live in a monsoon area, if you live in a La Nina area, if you live in an equatorial area, talk about your place. Say how the La Nina during certain times of the year will lead to heavy rainfall of more than 2,000 millimeters a year, which then leads to significant rain splash erosion. As you can see, you don't have to relate it to rain splash erosion. You just have to somehow link it slightly by saying how there's a lot of rainfall, which suggests that there is a lot of rain splash erosion. You don't need a specific case study or example of rain splash erosion. That's what I'm trying to say. For sheet wash, you can draw a diagram like this. Rainwater, so rain, and it's going downwards. And then you define it as an unchanneled flow of a thin layer of water. And then you have to explain why that happens. Why does sheet wash happen? It happens because it happens when precipitation rate is greater than the infiltration capacity, so there's more rainfall than the slope can soak up, or when the soil is impermeable because it's saturated perhaps. So when it's full of water, it can no longer take in more water, so it has to slide down the slope. And then if you want an example, just talk about another place with a lot of rainfall where it is likely that slopes are filled with water so much that it can't take in more water and has to flow out in sheet wash. And you can talk about places. I talked about Malaysia with 3,100 millimeters of rainfall a year, and the examiner credited it as an example given. So after you talk about sheet wash, you can talk about how it erodes things. So how it has velocity to entrain the material, which starts to erode the surface of the thing. And lastly, you can talk about rills and gullies. So rills and gullies are kind of just like this. And it's just water flowing down. You can define it as a shallow channel of water, and it can be from the sheet wash. So you can link it from sheet wash to rills. The sheet wash concentrating in cracks or depressions in the slopes. And then you can add in how the cracks form in the first place. It can form through rain splash erosion, or it can form through dry conditions cracking the slope. I explained this all in my rills and gullies videos. I talk about everything here, and then you can talk about how it will widen and enlarge into a gully, so it becomes something like this bigger one. Right? It's just very simple diagrams, very simple explanation. And if you want an example, just remember an example. I remembered Kenya, and I wrote an example of this is the Kenyan Badlands, and I got a credit for the mark. It's very simple examples. You don't really need that much detail, especially for the 8 markers and 7 markers. So yeah, you can definitely do well without having to remember that much detail, essentially. And there you get an easy 8 marks. For 6C, this is your big case study questions. Every section has the 15 marker, and it wants you to use examples, as you can see, with the aid of one or more examples, with the aid of examples, and with the 8 examples. And these questions always ask something. How far do you agree? How far do you agree? Evaluate attempts, right? So it wants you to come up with a judgment. And for evaluate attempts, it's primarily talking about how successful or effective something was. So how effective has attempts to reduce mass movements been. You can pick 3 or 4 case studies and because there's so much management techniques, you can't fit them all, so you have to pick the best ones. So pick the techniques that you can talk about a lot. In my essay, I talked about drainage. I talked about pinning. And I talked about greening. But if you have a big case study where you can evaluate the use of shotcrete, for example, use that. If you have gabions, if you have rock walls, use that. You don't have to stick with what I use. Just basically do the ones that you can remember the most, because after all, it's a big question where you have to add in a lot of detail. I'm going to go down to this page to show you how you should plan a question like this. So you should plan something like intro, P1, P2, P3. If you write very fast or you have little to say, you can add a P4 if you want, but generally I stick with a 3-paragraph essay, and then you add a conclusion. So in your intro, you want to have your definitions in. So you start off by saying what something is. So for example, I'm going to talk about mass movements. I define mass movements as large-scale movements of the Earth's crust, for example. And that is like a okay starting sentence if you want, and it just gets you in the flow of writing the essay. After you add in your definitions, you can add in the context and introduce your points or case studies. So context, by that I mean drainage is used in Malaysia or Hong Kong, for example, and that's just introducing what you're going to talk about. So introduction of points. So you're just briefly mentioning what you're going to talk about and as an introduction sentence. And then you have to add your judgment over here. Basically, spoil the beans, spoil what your ultimate opinion is. And you can say attempts to reduce mass movements have been somewhat successful or somewhat unsuccessful or moderately unsuccessful. There are 2 ways of coming up with a judgment. I'll write this down over here. And number 1 is the extent way. Extent is something we can say it's like on a continuum. So here is complete unsuccessfulness, unsuccessful, and this is complete successfulness. And then you can talk about where you stand on this continuum. You can say it's it's mostly successful, or it's neither. I wouldn't recommend sitting on the fence, but you should go like slightly or slightly not. You can be moderately not. Just pick somewhere in the continuum you want to argue for. Another way is the nuance way. And this is where you say, in this context, it has been successful, but in another context, it hasn't been. And this can be through things like regulation of areas. So if well-regulated areas use attempts to reduce mass movements, it works, whereas attempts to reduce mass movements in unregulated areas have been unsuccessful. You can talk about the time scale. So in the short run, it's very successful in reducing mass movements, but in the long run, it ultimately is unsuccessful because of something. Or you can talk about HICs and LICs, which relates to the regulation parts. If you can think of a nuance, I think it's the best way and you get really, really good marks. Obviously, extent is very easy, but if you're a professional essay writer, or if you think your essay skills are quite well, you can think of original ideas. Nuance is the best way to go, which shows you you're way ahead of the curve in the AS and A-level taking students. I went with extent in my essay. So as you can see, I got 14 out of 15. So even if you use extent, you can score really high. But nuance, I think, is just really good. Even not even for the exam. It's good for the exam. It's good for your own personal skill development as well. But after you come up with a judgment, so for example, attempts to reduce mass movements have been moderately unsuccessful. You then need to add in your thesis statement. And the thesis statement is the main argument that you're going to thread through all your P1. So this argument has to relate to P1, to P2, to P3, and repeat it in your conclusion. And what I mean by this is essentially why you come up with that judgment. Why do you think it's moderately unsuccessful or slightly successful? So say something like attempts to reduce mass movements have been moderately unsuccessful because in the long run, the management techniques will inevitably break down due to exposure to the elements. So it's kind of combining these two in a sense, but just adding a bit more explanation to it. You don't have to explain too much in detail, but make sure it's something that you can sustain in every argument. So you seem better. If you want to talk about a nuanced one, it can be attempts to reduce mass movements in regulated areas have been successful, whereas attempts to reduce mass movements in unregulated areas have been mostly unsuccessful because management techniques have to be well thought out and planned before they are implemented or something like that. So as you can see, that argument has to be furthered out. So if that's your argument, you have to talk about regulation in P1, P2, P3, and other things. Obviously, you can talk about more evaluative points in your essays. You don't have to stick strictly with the thesis statements, but make sure you have that link throughout. So I'm not going to go into P1, P2, P3 because that's a lot of detail, but I'm going to kind of teach you how to structure your main body paragraphs. For physical geography, draw diagrams, right? It's easy marked, it's easy to visualize for the examiner. Diagrams are just a good way for you to gain marks. You must use examples because the question specifically asks you to use examples. So for drainage, I use the example of Malaysia and Hong Kong. For pinning, I use Hong Kong. For greening, I use Hong Kong and the Philippines. And these comes from the case study and my external reading of these techniques. So these are the things you have to keep in mind, but how do you actually write your main body paragraph? Well, you have to have a starting sentence. So your starting sentence must be clear. And it has to be clear on what you're going to talk about. So if your paragraph is on drainage, then talk about drainage. Say, a management technique of mass movements that has been somewhat successful is drainage, full stop. That shows the examiner that you're going to talk about drainage in that paragraph. Talk about pinning, say pinning. If you want to talk about greening, say greening. Make sure that the examiner knows what you're going to talk about because that just makes everything structured and makes them like you more, so they might give you more marks. So after you have that, you need to explain why your point works or how your point works. You talk about drainage, explain, analyze how drainage works. Say drainage works subsurfacely or on the surface where it removes water from the slope, which prevents lubrication of the slip plane, which means that it prevents the reduction in shear strength, which leads to less mass movements, right? That is a basic and explanation point. And then you have to use examples. So after this, use examples. After you explain, you say this, for example, has been done in Malaysia, where it has been very successful in removing the water. Malaysia has 3,100 millimeters of rainfall a year. So drainage is very necessary, otherwise mass movements would occur more frequently. So that's an example, and you want to use the example to show, has it been successful or not, has it worked or not. In the case where I just explained just now, Malaysia has been successful, but in areas, for example, Hong Kong, it might not have been successful. So for example, in the drainage in Hong Kong, it's not well enforced. People have confusing responsibilities, which means that they poorly manage it. So sometimes the drains themselves may become slip lanes. They might add mass to the slope if it's clogged up, and in that case, evaluatively, that leads to some issues. Another evaluation point can be the pipes are very expensive to the pipes, because they are plastic made out of PET especially, they crack easily, they break easily, so they need to be replaced frequently, which is expensive. So if you're a poor country like the Philippines and Guinea-Bissau, you can't really afford that much drainage, and you can't afford to replace it constantly, which means you might not be able to use it. So it is an issue if you have financial issues, for example. If you don't have the financial means, you probably can't use it effectively and it would just break down. So as you can see, it's a really clear structure. You start off with your points, make sure the examiner knows what you're going to talk about, then explain it in detail, how it works, how drainage works, how pinning works, and then use examples to back it up. Where has it been used? And then use the examples to evaluate it. Has the place where it has been used, is it successful or is it unsuccessful? Why has it been successful? You have to explain the evaluation, and you can use evaluation that isn't related to the examples. In my exam, when I talked about pinning, I said how if your pinning is like this, where it is higher up instead of lower down, then that adds mass to the slope, which increases your shear stress, which might lead to more mass movements. And I didn't have an example to back that up, but that is still an evaluative point if you can put it in. So evaluation, if you watch my video, can come from examples or it can come from theory itself. It's just finding any limitations of that issue. But if you can clear any limitations, then you can show that it is actually quite successful. That is how I explained pinning. For example, I said that even though that is the case, it has been effective in a lot of places where in Malaysia, for example, there has been almost no mass movement since the implementation of pinning. So after you have your 3 paragraphs, you have to come up with a conclusion, and the conclusion is where you restate your judgment. And then you expand on your thesis and whatever you have talked about. So if you had talked about regulation in your whole paragraph, you can start talking about how regulation will affect things. If it can be used effectively, then it is effective, right? You can say how they all have their disadvantages, but if it's regulated well and used in the proper way, then it will have its proper advantages. But if it's used unregulatedly, then it won't have its advantages. If it's used in an LIC where it's expensive and you can't really repair it, then it's not really useful, because in the long run, it's gonna be deteriorated due to weathering itself, and then you're not gonna get the desired effects in the long term. So you can add more evaluative points. So it's like extra evaluation, but make sure that whatever you're talking about, your conclusion, has to come from your P1, P2, P3, or introduction. If you're adding something completely new, you're doing something wrong. You have to make sure that you're explaining things, you're evaluating things in your main body paragraphs to use to summarize in your conclusion to form an ultimate judgment. And with this structure, that's how I got 14 out of 15 for this question. 29 out of 30, only lost 1 mark. And that's how I got 51 out of 60, which is top in the world for this exam season and this paper. So I hope you guys enjoyed this video. If whatever I said has been confusing, this has been a long video, please just drop a comment and let me know. I know sometimes I trip over my words, but if there's no other questions and you enjoyed this video, drop a like, subscribe, share with your friends, and I'll see you in the paper 2 video next time.